This is a National 5 Maths video and looks at the converse of Pythagoras. So we are learning how to use the converse of Pythagoras to prove a triangle is right-angled or not. We will be successful if we can find the sum of the squares of the two short sides of a triangle and the square of the long side of the triangle, and then compare these to prove whether the triangle is right-angled or not. So we know, or we should know, the theorem of Pythagoras, which states that if a triangle is right-angled, it contains two short sides, which can be squared and added together, and this will give the longest side squared. So we can use this theorem to prove whether a triangle is right-angled or not. Example 1 shows a triangle with two short sides, 20 and 21, and the long side of 29. So all the sides are there. We want to prove if it is right-angled or not. So this time we're going to follow Pythagoras' theorem, which takes the two short sides, so 20 squared and 21 squared, and we're going to add those two short sides together. This gives us a total of 841. In a separate calculation, I am going to then square the longest side, which is 29, and this also gives me 841. What we can see here then is that if we square this short side and this short side, it totals the longest side squared, and therefore we have a right-angled triangle. Now what is important is the statement that follows. We must write a sentence to confirm this, so we need to say that since the two short sides squared and added together equal the long side squared, the triangle is right-angled and we have done this using the converse of Pythagoras. So we want to say it is right-angled by the converse rule, the converse of Pythagoras. Okay, let's have a look at a second example. This time we've got a rectangular picture frame which should be made. It has 30 centimetres high as shown, 22.5 centimetres wide, and we want to check that the frame is rectangular. So for anything to be a rectangle, it must contain right angles at each corner. The diagonal is measured here, it is D, and it is 37.3 centimetres long. The question is the frame rectangular? So by completing Pythagoras, or proving that the rectangle is right-angled, so we want to first of all square the two short sides and add them together. So 22.5 squared, add 30 squared, and that gives us 1406.25. We're then going to take that diagonal, which is 37.3. We're going to square it, and that gives us 1391.29. This time, because the squares of the short sides added does not equal the long side, the diagonal squared, the triangle is not right-angled, and therefore the rectangle is not rectangular. We want to therefore make this statement. So we want to say, since the two short sides squared, so we'll just write that within the sentence, do not equal And the symbol for does not equal is an equal sign with a line through it. Does not equal 37.3 squared. The triangle is not right angled by the converse of Pythagoras. And then we also want to refer our answer to the question, which means that the frame is not rectangular. And it is very important in National 5 that, as well as the statement in our decision, that we explain that decision and we justify our answer. So since 22.5 squared plus 30 squared does not equal 37.3 squared, the triangle is not right angled by the converse of Pythagoras, which means that the frame is not rectangular. So remember, when we're answering questions like this, we want to do two separate calculations, one with the short sides squared and added, one with the long side, two separate calculations. We then compare the answer, we make a statement, and we include the converse of Pythagoras in our answer. And we also have to think about the question, so we may have to refer to the question in our answer as well.